Alright, so let's have a look at question 1 of the 2010 Exam 1 paper. Alright, so our first question, part A, asks us to differentiate x cubed times e to the 2x. Now whenever we can see a function multiplied by another one, so if I put a little dot in there to represent multiplication, we need to think about the product rule. The product rule for differentiation. And if you've got a data sheet handy, hopefully you can see that it expresses the product rule as the derivative of u times v equals u times dv dx, which is the derivative of v, plus v times du dx. Alright, so in this case, what I'm going to do is I'm going to call x cubed u. I'm going to let v be the e to the power of 2x. So if I just write it out here, we're letting u equal x cubed. So du dx, the derivative of x cubed, is just power out the front, 1 off the power. So v is e to the 2x, and dv dx is just the coefficient out the front this time, and we leave e to the 2x alone. Alright, so our product rule now says that we pick up these two bits of information and multiply them together. So we're going to have u is x cubed, and we're going to multiply that by this guy, dv dx, so that's going to be multiplied by 2e to the 2x. And then we're going to add on to that, because of this guy here, we're going to add on to that the multiplication between these two pieces. So v, which is e to the 2x, multiplied by 3x squared. And now, perfectly happy with all of that to get our 2 marks. We've shown working, and we've got an answer right here. I'm just going to clean it up a little bit. So I'd probably bring the 2 out of that front equation, so I'd have 2x cubed e to the 2x plus 3x squared e to the 2x. Alright, so part B says for the function f of x equals log e to the x squared plus 1, find f dashed of 2. So this time it's not a product rule, and it's definitely not a quotient rule. Instead, we've got to use the chain rule, because we can identify a function inside another function, if that makes sense. So just clean that out of there. So our chain rule from our formula sheet is expressed as dy dx is equal to dy du by du dx. So what's this u business? And for that matter, what's the y business? So what I'm going to do is I'm just going to call this guy y. So we have y equals log e to the x squared plus 1. And then I'm going to turn this inner function into a u. So now we can express this as y equals log e of u. So dy du equals 1 on u. And now we're going to work out what our u part says. So u equals x squared plus 1. So du dx, the derivative is just power out the front, 1 off the power, and a constant just goes to 0. So we'd have a plus 0 in here that we don't need to worry about at all. So now coming back to our chain rule up here, we take dy du here and we sub it into here. So that equals 1 on u, and then we multiply that by du dx, the inner function. So we multiply that by 2x. So at this stage, we've got dy dx equals f dashed x, if we're really particular about our notation, because up here we did have an f. We've got that that's equal to 1 on u. We know what u is. We've got u equals x squared plus 1, so we'll put that there, x squared plus 1, by 2x. Oops, sorry. By 2x. And just clean that up a little bit by putting that on the top line, x squared plus 1. Alright, so we're nearly there. The only trick is we're required to look at f dashed of 2. So if we put 2 into this equation here, we'd have 2 times 2 over 2 squared plus 1, which is going to give us 4 on 5. So just to make that really explicit, we've got f dashed of 2 is equal to 4/5 or 0.8. Personally, I would never decimalize because fractions are generally easier to work with and you'll probably only make a mistake when you go to a decimal answer. So that's our answer. That's just to make that clear. That is equal to it, but my recommendation is not to go to a decimal answer. Not.